Hello, game theorists. Today we are in Chapter 6, looking at combining sequential and simultaneous games. So we have this distinction earlier between sequential and simultaneous. With sequential games, the players took turns. With simultaneous move games, the players moved without knowing what the other player would be doing. We developed separate tools to analyze each kind of game. With sequential move games, we had a game tree. With simultaneous move games, we had a table which we called the normal form or the strategic form of the game. It turns out you can use game trees to analyze both kinds of games. You can also use tables to analyze both kinds of games. The usefulness of this is that it's going to illustrate more clearly the distinction between a Nash equilibrium and the rollback equilibrium. So we have seen one example already of the same game being represented in different forms. So we had our market entry game earlier. This was back in, I think it was chapter 3, if memory serves. So firm 1 was in a market, and firm 2 could decide if they want to give them some competition or not. So firm 2 might choose to not enter and let firm 1 retain its monopoly status. Or firm 2 could enter and provide competition. Firm 1 then had to decide if they want to charge a high price so both firms get big profits. Alternatively, firm 1 could pick a low price and try to put firm 2 out of business. And the payoffs were firm 1 on top and firm 2 on the bottom. So we did a rollback and we established that firm 1 would rather get the high price, payout of 4, rather than go into a price war and get -1. Consequently, firm 2 could choose to enter because they know this threat to play low price is not going to happen. We then showed the same game being played as a simultaneous move game. So firm 1 could pick the high price or the low price. And firm 2 could pick enter or not enter. So they don't enter, then game ends, firm 1 gets 10, firm 2 gets nothing. If they do enter, they have the 4/4 if they go for the high price, -1, -1 if they go for the low price. And we did our best response analysis. So if firm 1 plays high, then firm 2 wants to enter and get 4 instead of getting 0. If firm 1 plays low, firm 2 wants to play not enter and get 0 instead of getting -1. If firm 2 plays enter, firm 1 wants to play high and get 4 instead of getting -1. If firm 2 plays not enter, then it doesn't matter, you get 10 either way, so these are both best responses. So there are two Nash equilibria, high enter, low not enter, but there's only one rollback equilibrium, enter high. So back then, when I pointed this out, I promised I'll talk more later on about the difference between Nash and rollback. Here I'm going to fulfill that promise and go into more depth on that topic. So the first thing I'll do when combining sequential and simultaneous move games is be able to go from a sequential game to a simultaneous game. Once we have that figured out, will go in the other direction. So we learned earlier what the definition of strategies was for sequential games. So we take each one of those strategies and make them either a row or a column in the table when you're setting up as a simultaneous game. So the market entry game is a very simple example of that. Firm 2 had two strategies. That meant we had two columns, one column for not enter, one column for enter. Firm 1 also had two strategies. They could play low or they could play high. I made Firm 1 the row player. That meant we had one row for the low price and one row for the high price. So it's a very basic example. Let's try something a little bit more complicated. So we have two players. Let's say player 1 is Jake. And Jake can play either A or B. Player 2 is going to be, who's player 2? Player 2 is Richard, let's say. Richard can play either X or Y. So our payoffs are going to be, I'll put Jake's payoff on top. So here will be 1, 1. And this will be 0, 2. Minus 1, 1. And 3, 0. So remember, a strategy says, we said earlier, that it says what you'll do at every one of your nodes. So Richard has two nodes, so he has to specify what I do at each one of those. Consequently, Richard has 4 strategies. Jake has 2. So I just list them all out. So Richard could play X if A, X if B, X if A, Y if B. So Y if A, X if B, Y if A, Y if B. I noticed earlier, but I'll just recap it briefly. Make sure you have some pattern when you're going through the possibilities. So I changed the last one first from X to Y, X to Y. Once I exhausted that, I also changed the first one from X to Y. If I do it in this according to this pattern, then I know I'm not going to miss any possibilities. So Jake has two strategies. That means we'll have 2 rows or 2 columns in our table depending upon where I put Jake. Richard has 4 strategies, so Richard has 4 columns or 4 rows, again depending upon how I want to set this up. I'll put Richard over here. I'll make him the row player. Doesn't actually matter, of course, you make either player the row player or the column player. They're both equally valid. So Jake can play A or B. So I write XX for X of A, X of B. And here's X of A, Y of B, and there's also Y of A, X of B, and there's YY. So let's fill in our payoffs. So here, that means Jake's playing A and Richard is playing X. That's right over here. In that case, both players are getting 1. In this case, Jake is playing B and Richard is playing X. That means we're over here, BX. Jake's payoffs are on top, so that means Jake is getting -1 and Richard is getting +1. All right, next cell. X if A, Y if B. So Jake is playing A. Richard plays X if A. So we have A, then X, so over here. That means 1, 1. In this case, Jake plays B. Richard is playing Y if B, so that means we're going to be down here, B then Y. That means that Jake is getting 3 and Richard is getting 0. Moving on. Here Jake plays A and Richard plays Y if A. So we have A, then we have Y. We're over here. That means Jake gets the 0 and Richard gets the 2. In this case, Jake is playing B. Richard replies by playing X if B. So you have B, then we have X. BX is over here. Jake's payoff is on top, so Jake's getting the -1, and Richard is getting the +1. All right, lastly, we have the YY row. If Jake plays A and Richard plays Y, we are over here. Richard gets 2 on the bottom. Jake is getting the 0. And this final cell, we have Jake playing B, and we have Richard playing Y. B then Y takes us here. Jake is getting 3, and Richard gets nothing. So that's how I translated this game that was sequential into a simultaneous game. I listed out all the possible strategies for both players, then I made a row or a column accordingly for each strategy. It took a little bit of work to figure out how to rewrite these payoffs over here, but nothing unmanageable. Now for some analysis, let's see if the rollback and a Nash equilibrium are different. So, if you want to get some practice, go ahead and pause the video, try to find the rollback equilibrium here, and try to find the Nash equilibrium here, and when you're ready, press play and we'll see if you're right. Okay, I'll assume you've given this some thought. Let's start with rollback. So you start at the end and you work your way to the beginning. We have Richard over here. Richard's payoffs are on the bottom, so he cares about that bottom number. He'd rather play Y and get 2 than play X and get just 1. What about over here? So Richard could play X and get 1. That's better than playing Y and getting 0. Now we go back to Jake's decision at the start. Jake knows if he plays A, Rich will respond with Y, which gives him nothing. If he plays B, though, Richard plays X, and that's even worse for Jake. Jake is -1 in that case. So Jake's going to want to play A. So that's our rollback. Now let's do our Nash equilibrium. Our usual tool here is best response analysis. If Jake plays A, what is Richard's best response? These ones give him 2. Those ones there give him just 1. So these are the best responses. If Jake plays B, best responses are here, which give Richard 1 instead of getting 0. If Richard plays XX, Jake will want to play A and get 1 instead of getting -1. If Richard goes for this strategy, Jake wants to play B and get 3 instead of getting just 1. And against this strategy, it's better to play A and get 0 than play B and get -1. Against YY, it's better to play B and get 3 rather than play A and get 0. So our Nash equilibrium is Y if A, X if B, A. The rollback so Jake plays A, and Richard replays Y if A, X if B. So Y if A, X if B. So you compare, they're the same thing. Either way, Jake plays A in both rollback and Nash. Either way, Richard plays Y if A, X if B in both rollback and Nash. So it turned out in this game, Nash equilibrium and rollback happen to be the same. We know from the market entry game, though, that we saw earlier, that Nash and rollback are not always the same. So that's how you go from sequential games to simultaneous games. To go in the other direction, be sure to tune in for our next episode.